Hello guys, welcome back to Med Zone African Motives, still on Mechanotechnics N5, working on bucket elevators and bucket conveyors in this case. So that's one of the most important topics, one of the direct topics actually that we have. It's important because of the issue of marks. They've got a lot of marks, but if you check the stages, they are very, very direct. All you need is your information, how to take your information and the calculations that follows. So we are given that there is a bucket elevator used to transport coal, and yes, got the following details. All right, so this is our August 2023 paper. So these are the details that we are given about our bucket elevator. So we are given the center distance between the head and the tail is 100 meters in this case. So we have got C represents the center distance in this case, which is 100 meters, all right? So that is our center distance. This is represent your center distance with a bucket spacing of 700 millimeters. So take note, our spacing is 700 millimeters. So we are given the spacing of 700 millimeters. If you convert to meters, you're going to divide by 1,000, which is going to be 0.7 meters. So that is our spacing. At a chain speed of 75, take note, meters per minute, our velocity, which is the speed, is supposed to be in meters per second. So we are given the speed, which is V. So remember V for velocity, which is the speed of the chain. It's 75 meters per minute. Instead, it is supposed to be in meters per what? Per second. So this is 75 meters per minute, which is supposed to be in meters per second. So how do you convert a minute to a second? We are going to divide by 60. So we're going to have 75 meters over 60 seconds. 1 minute is 60 seconds. So that will give us something like 1.25 in meters per second. So speed is supposed to be measured in meters per second from the distance that we are given. Our speed is going to be in meters per second. Then we are given the mass of tons is transported at an effective shift of time, which is 8 hours. So we are given the mass in tons transported per given time in hours. So we are supposed to have our mass as in kg per second. So we are supposed to obtain mass per second, which is mass in kgs per second. It's supposed to be kg per second. So here we are given tons. Take note, it's 1,200 tons in this case. So we are given 1,200 tons per 8 hours. The hour time is 8 hours. So meaning to say we are supposed to change this to kgs per second. So this is in hours. So how are we going to convert to kgs per second? Remember, a ton, in 1 ton, we've got 1,000 kgs. In a ton, we've got 1,000 kilograms. So that is going to be 1,200 times 1,000 kgs in this case. Everything over the time in hours to be converted in seconds. 1 hour, remember, is equivalent to 3,600 seconds. So meaning to say, we are going to divide in this case by the time that is in hours of 8 hours times 3,600 seconds. So that this time is going to be in seconds so that we obtain our mass in kg per second. All right, so if you are going to do this, you are going to obtain your mass now as 41,667, which is measured in kilograms per second. So be careful on that part. And also we are given the discharge in case the discharge of coal takes place at 30 degrees after the top dead center. So this is the discharge of coal in this case that is happening, which is theta. So theta represents the discharge, which is 30 degrees in this case. All right. So the question is, let us see our question, calculate the following. So this is our question, calculate the following. The diameter of the head pulley. That is 4 marks for that, to calculate the diameter of the head pulley. So what are we going to do with the given information or with the given data that we have? What are we going to do to calculate the diameter in this case on question 3.1? So we're supposed to calculate the diameter. We do not know our diameter, but remember that from the velocity of the chain, which is the chain speed in this case, remember that the velocity of the chain speed is given by pi dn over 60, whereby n is the speed in revolves per minute, d is the diameter. But here we do not have the speed in revolves per minute, or the same velocity is given by the square root of the gravitational acceleration times the cos theta, which is our discharge times the radius in this case. So meaning to say, in order for us to have diameter, we are supposed to be focusing, we are supposed to be thinking of this formula that is for the radius, because we've got the discharge, gravitational acceleration being 9.81 meters per square second. And we have the discharge, so we also have the velocity of the chain, which is the speed of the chain in meters per second. So meaning to say we can calculate the value of R, which is the radius. To calculate R, after calculating R, diameter is equal to 2 times radius. Remember the concept between the diameter and the radius. So that is what we could have applied in this case. We could have used this information that we are given here. So meaning to say, let us, we can make this the subject, R the subject, or you can just substitute in this case the values that you're given. Your velocity in this case, that is 1.25 meters per second, is equal to the square root of the gravitational acceleration of 9.81 times the cos of theta, which is in degrees. So the discharge is in degrees. So it's going to be cos 30 times the radius in this case, which is the one that we do not know. If we are to calculate the radius, therefore we can calculate the diameter by multiplying it by 2. So how can we calculate the radius in this case? That is our question. How are we going to calculate our radius? So that is how you're going to ask yourself. So it's a matter of substitution in this case. I mean, a matter of change of subject. We can remove the square root where R is E is. Here by squaring both sides, we are removing the square root by squaring both sides. So it's going to be 1.25 squared. So here, let us have our calculation. So this is going to be 1.25 squared. All right, so you're going to have 1.25 squared, which is equal. We have removed the square root. So we are going to be left with the 9.81. This part as it is under the square root, 9.81, the cosine of 30 degrees times the radius. So in order for us to find the radius, we are going to divide by this part here since we are multiplying. So we are going to remove this by dividing by 9.81, the cosine of 30 degrees. The same thing here, 9.81, the cosine of 30 degrees. All right, so that is what you are supposed to have to obtain the radius in this case. So simplifying this, we are going to obtain our radius as 0.1839116 and so on, which is going to give us something like 0.184 in this case if you round off to 3 decimal places. That's in meters. Remember, your velocity was in meters per second. So this radius is going to be also measured in meters, not millimeters, unless you want to convert to millimeters. So the question was to calculate the diameter, not the radius. So from this part, we say diameter is 2 times the radius. So that means our diameter, therefore, our diameter is going to be 2 times the radius that we got in this case, which is 0.184 in meters. So this is going to give us our diameter, which is going to be 0.368. So we're going to have 0.368, which is measured in meters, as we took this one in meters. If you want to convert to millimeters, you multiply by 1,000. So this would be something like 368 millimeters. That is, if you want to have your answer in millimeters. So as you can see, this topic is an application of formulas in this case. From what we are given, we just have to apply our formulas. Let us see what we have gained from this question. We are now asked to calculate the total length of the chain. In this case, the total length of the chain, assume the same diameter for both the head and the tail pulleys. Ignore the deflection of the chain given by the tension device. All right, so take note, this is on a pulley, like we are given a pulley in this case, like let us say this way. We have got, if you check properly, we need the total length of the chain. So it will be like this. We are having, that's 3.2. So we are having the head, pulley, and the tail, which is the top and the bottom in this case. So we are having something of this nature. This is our chain in this case. All right, so let us consider this way, something of this nature. So this is our chain in this case. This is our chain, the one that is surrounding on top. And also here, let us maybe use the dotted lines. Okay, so this is the part of the chain in this case. So we are going to see that this chain is affected on this part. It's affected by half of the circle on this part here. It's affected by half of the circle. Remember, a complete circle, its circumference is 2 pi r. So half of a circle is going to be pi r. So we are going to use pi r for the length of this half circle. This is where our chain is affecting here. This chain is affecting this part, which is part of a circle, but it's not the whole circle, because the chain is going like this. This is your chain, this one, the outer part. So we are not focusing on the inner part. The chain is not entering inside. So it's not a complete circle. You need outer part, which is the perimeter or the total length. So like I said, this is a half circle represented by pi r. On the top again, or on the head, there is a half circle again on top here, which is also pi r. Remember, we said half of a circle is pi r. So we are going to see the length taken from this point here up to this point that is remaining. There's a length that is remaining from this point up to this point also, which is the same as on this side, the length that is remaining. That length is our center distance. That is called the center distance, C. So we are having C this side, also having C this side. So at the end, in order for you to have or to obtain the total length, in this case, the total length, that's why you see your formula is now L is equal to the 2C that we have here, these two, okay, the center distance. So we are going to have 2C plus the half circle on top and the half circle below. So it's going to be 2 pi r. So now we have a complete circle. Remember, a half circle, guys, and a half circle gives us a complete circle. So you're going to have 2 pi r there, which is now a complete circle. So this is the formula that we use to calculate the total length of the chain. All you need is the formulas, guys. All right, so the total length is going to be 2 times C. We have our C in this case. All right, on this information, C was given as 100 meters. So we're going to have our C, this one, in meters. So our C is 100 meters. All right, so we're going to have 100 meters plus 2 pi times r, which is the radius in this case. Remember, when we were calculating, we obtained a radius in this case on our calculations here of 0,184. This was our radius, 0,184. So we are going to take our radius as 0,184 here. So this is going to be 0,184. So that's it. We are going to obtain the total length of the chain in this case, which is 201,156 meters. So for the length of a chain, you round off to the nearest whole number. So this one, we can just say 201 or 202. So we're just going to have our length as 201 meters. In this case, we round off to the nearest whole number for the length of chain. So, but what is important, if this one is correct, then we can just say L is 201 in meters to the nearest whole number in this case. All right, so that was the question. To calculate the length of the chain, you need to understand what's happening on your diagram here with your chain. Then if you have to consider here, now they want us to calculate the driving motor's power. So we are supposed to obtain the driving motor power in this case. So the driving motor power, the power that affects the motor is the power in, this is P in. required if the drive is 81% efficient. So we are given the efficiency of 81%. All right, let us have this on our formula and talk about this on a separate part. We want to calculate the power that is affecting the motor in this case, the drive motor in this case. And I'm saying these two, they are related from the efficiency. Which two are we talking about? The driving motor power, which is 3.3, all right, which is P motor in this case. So the power of the motor, this one, is our P in. This is the input power. Then we have got the power that is to lift the load against gravity, which is GPG, the power to lift the load against gravity, which is PG, which is P out in this case. This PG is given by the formula mgh, mass times gravitational acceleration times the height from gravity, that potential energy in this case, the power to lift the energy stored, the energy that is stored. We are talking about potential energy there. All right, so the question is, we are given efficiency, and we know that from efficiency, we understand that efficiency is given as the power out over the power in times 100%. Power in, power out over power in times 100% in this case. Okay, so remove the 100%, we divide by 100. So this power out is the one that we are saying it's PG, this one, PG. That is our power out. The one that is due, the power that is to lift the load against what? Against gravity. And P in is the power of the motor. So we can rewrite our formula as the efficiency is equal to P out, which is our PG in this case, the one due to the gravity, over the power in, which is the power of the motor. So we want to calculate the power of the motor in this case, which is our power in. So that's it, times 100%. So that's, in this case, we can calculate the power of the motor, but we do not have this one. We do not have PG. Yes, we've got our efficiency, but the power to lift this we do not have. So where are we going to obtain this? We are going to apply the formula. All right, so let me take you back here. It follows that from our formula, we say the gravitational power due to gravity in this case, which is mgh, mass times gravitational acceleration times the height. It's supposed to be power. We remember it's supposed to be kilojoules per second. So the mass is supposed to be in kg per second. Then this is the height in meters. All right. So we have the mass, the gravitational acceleration, but we do not have this height. So where do we calculate the height? Height is the length of the chain divided by 2. Remember, if you raise this chain, it's gonna be like this. If you take it upright like this, this will be a chain. So we are going to take the height of it divided by 2 because it's given this way now. It's like a chain ending here and another one going there. We are not cutting this chain. So that's why we divide this one by 2. So it's gonna be the length over 2. So our h in this case, which is given from the height. So our h from the length of the chain divided by 2. So that means our h is gonna be the length of the chain, which is 201 in this case. So like I said, we are supposed to have this because it's going up, and at the same time, it is going to go down. All right. So it's going up, and at the same time, it's going down. So it is best for us to have this as a whole number so that we are not going to have like a breakage that we are saying is divided into 2. So what does it mean? We can have this as a 180, 82. So please do not confuse on this part. Do not confuse on this part what I'm trying to explain, to say it can be on a condition whereby it is going up and at the same time it is going down. So we can use the 182 for the basics of what? Of our calculation, so that we obtain a whole number also, because we are saying we have completed a certain portion on this part. We have completed a certain portion. Now we are considering another portion. We have completed one portion. We have to consider another portion also. Already this one is a completed portion. So it's gonna affect this portion that we have. If it is like that, if you are to use another as a whole number. So the part that you write, say, here is the one that is important, all right? So that part is very, very important. So if you are to use it as a whole number, I think from that explanation, you understand what I'm saying. So here we are gonna have 201, all right? So that's 201 over 2. That's our H. If we are to divide by 2, we're gonna have 0.5 meters. So that's we are going to use our H now to calculate the power, which is our PG, using the mass in kg per second. And already here, when I was listing my information, I already converted our mass here. If you take note, there was our mass here. We converted, remember, it was given as 1,200, this mass here before. It was given as 1,200 tons per what? Per 8 hours. Then we converted to kg per second, which is now 41,667 kg per second. So that is what we are going to apply. So we are going to use the kg per second. All right. So we are here. All right, sorry for that. We want this part here, right? So we're gonna use our mass as 41. So remember, we said this one is gonna be 41,667. All right, so that was 667. All right, 667. Which is in kg per second times the gravitational acceleration of 9,81 times the height in this case, which is 100,5 in this case. So meaning to say we shall have our PG as 41. So that will be 41079, 70 in this case. We're gonna have a 70 in this case, which is in watts. So if you want to write this in kilowatts, you can divide by 1,000. So that is going to be 41,0. This one is gonna affect this to 8. It's gonna be 0.8 kilowatts. All right. So this is the power that is we are going to use in order to lift the load against gravity. Now with this power, we can use it now to calculate the P in, which is the P motor. Remember our question, we are supposed to calculate the power that is by the driving motor in this case, which is our P in. And we formulated and said at the end, we're gonna have our formula using efficiency and so forth and so forth. So efficiency being 81% here, we can substitute our efficiency 81%, which is divided by 100, that's 0.81 is equal to PG. 41,08. Remember, this is in kilowatts. So if you use this in kilowatts, we are going to obtain our answer for the P motor in this case, which is our P in. P motor, it's P in. We shall obtain this in what? In kilowatts. So that was our question. That is how you play with the information. So meaning to say, you just need to know your formulas, this part of your formulas and so forth. Once you're at this stage, manipulate your formula now to remain with what? With the P motor in this case, since we want to calculate P motor. So we can just cross multiply, then we divide by 0.81. So it's gonna be 0.81 P motor in this case, which is equal to 41.08. This power, remember, it's in kilowatts. So we're gonna divide by 0.81, divide by 0.81 here. So we're gonna remain with the power that is affecting our motor in this case. So dividing this properly, we are going to obtain something like 50.716 in kilowatts. So that is how you attempt these typical questions. All you need when you are dealing with bucket elevators and bucket conveyors is the formulas. And with the aid of your formula sheet, we have these formulas. So all you need is to understand the principle of operation, especially also the idea of this pulley part that you are given, how to calculate the total length of the chain. The chain is affecting a half circle top and a half circle down. So you add those two, combine them, and also the solving part or the issue of the speed that is affecting our chain in this case. So with the speed of the chain, which can be calculated from this formula, the speed of the chain, which can be calculated from this formula when given revs per minute, or we can calculate from this formula here when given the discharge and the radius. So since you can use this formula to calculate the velocity, if they give you velocity, you can use it to calculate any of the unknown. You can even use it to calculate the angle of discharge. You can use it to calculate the radius, just like what we did. We calculated radius and used the radius now to calculate the diameter. So it's just a play around of questions. As you can see, it's just a matter of playing around with the formulas that you're given. So that's it, guys, for Mason African Motives. Till we meet again.